So the new CS45 2.5 watt BDA. There's its part number CS45-734834-0, and that's been available now and for the last couple months. So the CS45 half watt was known as being a really small and light BDA, and the 2.5 watt is the same thing. It is a small light BDA. Now it's a little bit bigger and a little bit heavier than the half watt, but it really is a very compact BDA for the output power. So there's its dimensions, 14 by 17 by 6 more or less, and the thing only weighs about 26 pounds. That's almost maybe half or more than half of almost all the other BDAs at that similar output power. It's NEMA 4. We have conduit ports on the bottom, and we have 2 end female RF ports on the top, donor and service antennas. Down at the bottom is an RJ45 port that is for the commissioning. It gets commissioned with your computer or your phone for that matter, and a web browser. That's all it takes. We have compression screw terminals inside for alarming, and of course it's wall mountable, it's lockable, and it does have a built-in alarm annunciator on the front panel. You can see it there, and the bottom LED is for oscillation, which makes it IFC 510 requirement compliance. If you would open up that lid, this is what you would see inside. Over here on the right, there's this module on the lid. That's just the printed circuit board for the alarm annunciator, and there's also a buzzer there for when an alarm goes off. This module here is the interface module. Anything that gets connected to the outside world is going to connect to that, including the fire alarm control panel monitor modules, the battery backup unit connections, transmit disable, which is another way of doing an emergency power off switch, and both a local and web graphical user interface RJ45 port. Over here in the lower left is the on-off switch. This little black button is the switch to determine if the lid is open or closed, and then we have this multi-function red button. If you tap it, it'll mute the audible alarm. If you press and hold it a little longer, the unit will reset, like turning it off and turning it back on. And if you press and hold it for a little over 10 seconds, it's going to do a factory reset and set all the settings as it was from the factory. And then something that's been added here is the downlink and uplink signals that are going to feed the fiber DAS. This is not on the half watt unit. All the half watt cannot be hooked up to the fiber DAS, only the 2.5 watt. And so pretty consolidated BDA, not a whole lot of individual modules. Like the half watt, this one works off of 12 volts DC, and under full load, full uplink, full downlink, about 123 watts. There's this operating temperature, -30 to +50 Celsius, and it's a 700-800 dual band, and the downlink frequencies and uplink frequencies are listed there. Let's look at the downlink. It's 851 to 869, and the uplink is 806 to 824. Those are in the 800 band. And for 700 band, 769 to 776, and uplink for 700 is 799 and 806. And you may have noticed on the 700 side that duplexer does not pass band 14 FirstNet. FirstNet is from 758 to 768 on the downlink, and our duplexer blocks that. Some of the features is both the donor and the service port. We measure VisWAR/return loss and display that in the graphical user interface. The power output is 2.5 watts or 34 dBm of downlink power per band. And that's adjustable in a 30 dB range, so from 34 down to 4 dBm in 1 dB steps. On the uplink side, we have 27 dBm, which is a 0.5 watt, And once again, a 30 dB adjustable range and 1 dB step, so from -3 dBm up to 27. On the downlink side, we have 90 dB of gain at the max, and once again a 30 dB range, so 60 to 90 and 1 dB steps. And for the uplink, 80 dB of gain, and once again 30 dB of range, so from 50 to 80 and 1 dB steps. This guy has 96 filter pairs, and by filter pairs I mean uplink, downlink, consider that a pair. So 96 channels you can put into this guy. And it's not like it's split half and half, 48 for 700 and 48 for 800. It's assignable in groups of 8 per band, up to a maximum of 80 filters per band. So look at that table there. Band 2 can have up to 80 filters, and then of course those 80 filters are both uplink and downlink. And then band 1 can still have up to 16. And then you can configure it any of those combinations that you see there, just in groups of 8. The filter characteristics, we have the Class A filters are 12.5 kilohertz, 50 kilohertz, and 75 kilohertz. And a Class B, 150 kilohertz. And we also have a wideband mode. In the wideband mode, we completely bypass the digital signal processor and just let the duplexer filter out anything above and below what it doesn't like. I do want to mention that with the half watt, we just had a firmware update, and a lot of it revolved around these Class A filters. And we made some real improvements as far as group delay and the roll-off, the characteristics of the roll-off. So if you haven't checked it out for a while, check it out. It's a big improvement. It has fast AGC and squelch, meaning it's phase 2, P25 phase 2 compliant. So P25 phase 2 is TDMA, time division multiple access. And the squelch and the AGC have to be able to switch from one level to the another level within 1 millisecond. This unit does that. And so does the half watt, and so does our CS40 product lines. It has a AGC dynamic range of 60 dB, and it has a relatively new feature for us. It was introduced last year, but it's automatic uplink amplifier shutoff. And if there's no uplink signals breaking uplink squelch for an hour, it will turn the uplink power amplifier off. And when it turns that uplink power off, you get 0 uplink noise. So yeah, that's what that was a PCERN, Puget Sound up in the Seattle area. That's a requirement there. So if you're in the Seattle area, know that this one is PCERN compliant. And it's a great feature. I mean, just picture any jurisdiction you've ever been in that someone complains about BDAs having uplink noise. Well, not this one. It's after, if nobody's using it, it shuts completely up. Great feature. And it has normal uplink squelch. And that's adjustable from -100 dBm up to -70. We have dynamic AGC. You can select one of 2 modes of how the AGC slices and dices the composite power up. So this thing can be on or off. And here's the scenario with 4 filters programmed. So 4 channels are programmed. With dynamic AGC on, if only one of those channels is breaking squelch, it can get full output power. So if you adjust this thing to have 27 dBm on the uplink, which is its full power, that one channel can get all 27 dBm. But if 2 channels now are breaking squelch, then they both can't get 27 dBm, so they'll each get half or 3 dB lower, and they'll each get 24 dBm. And then with 3 active channels, they each get a third, and then with 4 active channels, they each get a fourth, or 6 dB below the maximum output power. So the output power on the uplink is changing dynamically with how many signals are breaking squelch. Now if you compare that with dynamic AGC off, it just looks at how many filters are programmed, in this case 4, and it just slices and dices that up 4 different ways. So each of them will get a quarter of the power no matter how many signals are breaking squelch. So there's a possibility of getting less power on the uplink, but you get a very consistent power on the uplink no matter how many people are using it. So we don't really say which one's better or worse or more preferable. That's up to the situation out there, but at least it gives you the opportunity to choose which one is best for the building that you're working on. Now, even though it does have a built-in alarm annunciator, a lot of times you need a remote annunciator, and it uses the exact same one as all our other products. There it is right there. There's its part number. And it connects to the unit through Cat 5 or Cat 6, and it can go up to 3,000 feet away from the CS45. When it comes to the graphical user interface, it's browser-based, so if you like Chrome, Firefox, Safari, Edge, whatever you like to use, just load it up, type in the IP address, and you're off. You don't have to worry about a separate application. And don't have to worry about configuring the network. It's dynamic IP addressing, so you don't have to go into your network and make some changes there. Just dynamic will work just fine. And I can't say I've done a full commissioning with it, but I've definitely hooked up my Android, and I have an iPhone here. Hooked up a USB to C dongle, Ethernet adapter, and I was able to log in with both the iPhone and the Android. And I just have a couple of screenshots to show you how simple our interface is. I mean, it's simple, but it gets the job done. It's super easy. So this is the overall main screen where you can get to all the sub-functions. This is the alarm screen. This is RF configuration. And there's some other screens that I didn't show you, but I just wanted to give you an idea of how straightforward it is to commission this guy. Let's talk about its battery backup unit. It uses a new battery backup unit that none of our other BDAs use, so it's unique to this product. And that's the model number, the CS19 BBU005. And some of our products, the battery charger is in the BDA. Some of our products, the battery charger is in the battery backup unit. And in this case, it's in the battery backup unit. Which means that all the alarms that you associate with the battery backup unit, like low battery or battery charger fail or AC gone, are generated in the battery backup unit. So one way, shape, form, or the other, we need to get those alarms from the battery backup unit into the BDA, and I'll show you how to do that then. And the thing, like I mentioned earlier, works off of 12 volts DC. So we're not going to have 2 batteries in series like most other BDAs. Just 1 battery or 2 batteries in parallel. So 1 battery, this one right here, a 145 amp hour battery. You put 1 of those in there, it'll last for 12 hours. You put 2 of those in there with a parallel connection, and it will last for 24 hours. And I just have a picture here of just giving you the relative size of the unit and show you that at least where the battery charger is on the left, that panel just pulls straight out. The one for the battery, that is the door that hinges. All right, so how do you connect the battery backup unit to the BDA? Couldn't be simpler. The battery backup unit comes with 2 wiring harnesses, and on the end of the harness we have these connectors. These connectors are on the wiring harness from the factory. So this one will be the 12 volts, and this 6-pin one down here is all the alarms. And once those alarms enter the BDA, then we can view them on the alarm annunciator. All right, so that is the review of the new 2.5 watt version of the CS45. So now let's see how we get this thing to be an optical fiber DAS. So before we do that, let's just make sure we understand why we want to use a fiber DAS rather than multiple BDAs. So here's a large venue, and one BDA is not going to cover all the square footage of that thing. There's just not enough power coming out of a single BDA. So you could put multiple BDAs into this large building, but we're saying, nuh-uh, don't do that. Put in a single fiber DAS system instead. And then the other application you see fiber DAS a lot is multiple buildings on a single campus, where every building, or at least most of them, need to have a BDA in them. And we could put a BDA in building number 1, building number 2, building number 3, and building number 4. Or we could put a single fiber DAS system to cover all 4 of these buildings. We say put in a fiber DAS system. And what's wrong with just putting in multiple BDAs? Well, when you have multiple BDAs, you have multiple donor antennas. And when one donor antenna is transmitting a signal, there's a really, really good chance that other donor antennas or service antennas connected to that BDA will pick up that signal. And sometimes when that happens, you're going to get oscillations, timing issues, and increased uplink noise. And all of these issues go away with a fiber DAS system. All right, so here's the two of the 3 new products that we were releasing. On here on the left, this is the HE, the head-end unit, and its job is to accept the RF from the BDA, downlink and uplink, convert it into light, and send it to wherever it needs to go. This also has a alarm annunciator on its front panel. Now, once the HE converts the RF to light and sends it through a fiber optic cable, it's going to end up at an RE on the remote end. So the RE accepts the fiber from the HE. So the HE and the RE are connected through fiber optic. And it also has an annunciator built into it. And then from the remote end, we're going to connect the RF. Once it converts the light back to RF, we're going to send that RF to a remote unit, which I'll show you here in a bit. What is the fiber that goes between the HE and the RE? It's going to be single mode. It's not like it's a law or anything, but most single mode cabling has a yellow jacket. And then the connector needs to be SC APC. SC refers to the connection style or the connector style. In this case, the rectangle one that sticks and clicks into the socket. And then the APC represents the angled physical connector. And that's the shape of the glass of the actual fiber optic cable at the end. It can, the end of a fiber optic cable can be relatively flat or it can have an angle. We need it to be angled. And again, it's not necessarily a law, but most angled connectors are green. So if you have a green connector with a yellow jacket fiber, you probably got the right one. It has a 5 dB of optical link budget, so whatever fiber power goes into one end of this fiber optic cable, by the time it comes out at the other end, you shouldn't lose any more of 5 dB of optical power. And optical signals, they do reflect. Once the signal gets to the end of the fiber, some of the energy is going to be shooting right back to where it came, and we need to make sure that's 60 dB down from the original power going in. And you need to measure that with an OTDR, an optical time domain reflectometer. And just by the way, probably the number one thing that people mess up on is that they use the building's patch panel, and that patch panel has got to have the angles as well. So if that patch panel is any color other than green, it's probably flat, and you'll probably get a lot of reflections. So that is why we want the angled part of this ABC here, is this reflectivity. We don't want a whole lot of reflections, and angled connectors reflect a lot less light than a flat one. And if you put a patch panel in that has a flat surface, you're probably not going to meet this 60 dB of reflectivity spec. All right, so this is how everything gets connected together. So here's the CS45 2.5 watt BDA, and here's the 12 volts from the battery backup unit going to it. We are going to make 3 overall connections from the BDA to the head end unit, and these are the 3 connections that need to be made. There's going to be a Cat5 or 6 cable, RJ45 on both ends, and that's to shuttle the data back and forth between the master and the rest of the system. The gray lines here, that represents 2 different jumper cables that have SMA connectors on the end, and one is for the downlink signal and one is for the uplink signal. And then the HE unit doesn't have a power supply. There's nowhere to plug it in. So it needs to get its power from somewhere, and it's going to get it from the CS45. So we're going to send 12 volts from the CS45 over to the HE. So all of those get connected to the HE unit. And then the HE unit is going to take that downlink signal coming from the CS45 and convert it to light. And we can have up to 4 fiber optic cables connected to the HE. And as I mentioned, those cables are going to get connected to the RE. And what the RE is going to do is it's going to convert that light back into RF and then send it to the remote units. So the remote unit is pretty much a CS45 BDA, 2.5 watts, just about the same. The big difference is there's only one RF connector that gets connected to service ports. There is no donor antenna connector because it does not get connected to a donor antenna. And there's no uplink power amplifier either. So the downlink signal leaves the RE, goes to the CS45 remote, and the remote then gets connected to its own set of indoor antennas. On uplink, the process is reversed, except now this has the RF. It sends the RF through the uplink cable. The RE converts it to light. The HE converts it back down to RF, sends it over to the master unit, and then this master unit is what gets connected to the donor antenna. And that's about it. You know, the RE doesn't have any power supply either, so we hook up 12 volts to that as well. So with this system, we have 5 zones, or another way of looking at it, it handles 5 times the square footage as just a single BDA. Now, what if you have a lot of buildings or a very large building, and 4 remotes or 5 zones isn't enough? Well, we can daisy chain HE units. So right here, this represents what I just showed you, but simplified. 1 HE unit connected to 4 remotes. What we can do is daisy chain the power, the Cat5 cable, and then the RF jumpers to a second HE, and then that HE can also handle 4 remotes. And so in this configuration, we have 8 remotes plus the master, so this will be 9 zones, or 9 times the square footage as a single BDA. And this is with the firmware that was currently available. We're testing, and the long-term goal is to have even more than 8 remotes by, once again, cascading another HE. So not available yet, but hopefully soon in the future. If you've ever installed our previous version of the FiberDAS system, you know that we have this remote annunciator that will show you the status of not only the master, but all 8 remotes. This product works with this new system as well, so I can connect this up to an HE unit or a remote unit, and it will show me the status of every component in the system. And just like before, 3,000 feet. Now when ordering it, we have kits, which are always very popular. And if you don't know what we mean by kits, is on a single pallet, we're going to put the BDA, the battery backup unit, and its batteries. And you can order this with just one part number. So you order it with one part number, and then a little bit later it arrives at your door in one pallet, and everything is there ready to go. You don't have to worry about parts, one part coming in one day and another part coming another day. They're all going to be there. So this is the master unit right here. And then the K1 kit would be a 12-hour kit, and the K2 kit is a 24-hour kit. It has a 3-year warranty. And we also have the, again, here's the master unit. And here is the HE unit's part number. Here is the RE's part number. And here is the remote unit. So this is the CS45 without the donor port, and that's its part number right here. And you can get the remotes also in a kit. So down here is the remote K1 and the remote K2, which again is 12 hours for the K1 and 24 hours for the K2. And then here's the port, and here's the part numbers for the two different annunciators. And that concludes my presentation on the new product. And I'm going to ask Bob, do we have any questions that came in?
We do. We have several, actually. First one, are there plans for a half-watt to support fiber? I'll answer that one. We do have a half-watt remote in the pipeline. It's not ready yet, but stay tuned. Next question is from Casey. Are the frequency ranges still adjustable for NPS-PAC, for example, where it changes the noise crown like the half-watt?
What we have is the CS45 has a duplexer. Let me just... All right, so the duplexer itself will allow these ranges through. So downlink for the 700 is 769 to 776. And for 800, 851 to 869, and then here's the corresponding uplink. Now we have a couple different things that we can do with these frequency bands once they go in, and that has to do with the filtering. We can have up to 80 filters that allow anything in from 12.5 to 50 kilohertz to 75 kilohertz and call it Class A, or 150 kilohertz wide. Now, if you choose the wideband mode, then the wideband mode is just going to allow these bands through without going through the digital signal processing. Anything that comes through the duplexer is going to get amplified, unless for uplink, unless it's below squelch, or in this case, the uplink amplifier turns off because of that feature that we have. So from the uplink perspective, when the uplink power amplifier feature turns on, there is no noise crown. You can connect it up to a spectrum analyzer and you won't see 1 dB of noise increase. Now when the power amplifier is on, the power amplifier does have gain, and you will see the noise go up from thermal noise. But if squelch is on, then it will be reduced gain. But once the signal breaks squelch, you're going to get the gain that you're supposed to get, and you're going to see the associated noise with that as well, especially if the filter is wider than 12.5 kilohertz. So I'm not quite sure that answers the question, but that's the best I can do right now.
All right, thank you, Tom. The next question is from Andrew. Is this approved in Denver by chance? I'll answer that one. It is currently not approved in the city of Denver, and we are working with them to get their approval. The CS40 product line is approved for Denver. Next question, APC and not UPC.
Right, yeah.
APC, correct.
Yeah, absolutely. APC only. Don't ever use UPC.
Next question is from Casey. Do the alarms from the RF remotes transport to the HE across the fiber?
Yes. Yeah, so the master, it's not going to break out what remote has what problem, but if any remote has a problem, it'll show up as like a summary alarm. So if one of them, I don't know, the battery charger goes bad, The master will show a battery charger failure, but you'll have to log in to figure out which one has the issue.
Okay, next one is from Ben. How do you daisy chain the RF connections?
So the daisy chaining is only needed when you have HE to HE, so you have two of those. And inside the HE are contacts for the 12 volts. And you just hook up the two wires through spade connectors on one HE to the other one, no big deal. Both HEs have two RJ45 ports, and the second one is for daisy chaining. So if you only use one HE, you plug this blue Cat5 cable into that one port. But if you have a daisy chain, then you plug another one in and send it over to one of this one's HE's RJ45 port. Now there is no daisy chaining connectors in the HE for the RF. So these jumpers I'm showing kind of outside and not from HE to HE. So here, what you would need to do is you would need to put in a two-way splitter, an external one. So you would have two-way splitters, one for downlink, one for uplink. One output of the splitter would go to this first HE. The second output of that splitter would go to the second HE.
Okay, thank you. Next question is from Orlando. Does the system also monitor the connectivity to each DAS antenna from each RE?
No. So we don't have any way of monitoring individual antennas. The remote unit will tell us if the overall return loss / VISWAR is high, telling you that there's a big problem with the service antennas, but not any individual ones. There we would use a third party, and I don't know if this is Orlando from previously Dastronics, but that's the product that we generally use.
Okay, next question from Dylan. Assume that with adding HE and RE units that the BBU 12-24 hour stays the same.
Yes, yeah, there's headroom built into that.
Yep.
That was, yeah, definitely. Yeah.
Okay. Next from Richard, would you guys be willing to add to the BBU the ability to have it sit on the floor instead of the wall in case where the unit is being installed has no room on the wall?
Feel free to chime in if you disagree with me, Bob, but we do not, as like Westell, do not have a requirement that it needs to be on the wall. And it can certainly sit on the floor. Yep. Where I see it is there's some jurisdictions that just don't allow it. But if the jurisdiction allows it, yeah, just go ahead and put it on the floor.
Okay, next one's from Brian. Can the DAS annunciator be connected to a remote end unit and still display the status of the master and the other remotes, or does it need to connect to the master?
No, it can connect to any of the active components. It can connect to the master, the HE, or the remote.
Okay. Casey says previously you could adjust the ranges in the software where the BDA would only transmit 851 to 854 and 806 to 809. Is this still possible?
Oh, okay.
That's the clarification to the earlier question.
Okay. I could be reading it, but that's kind of what our CS14 BDA does. The CS14 is a Class B BDA, and it just has real physical filters of what you can select. Again, from an 800 downlink perspective, 851 to 854, 851 to 861, or if it's a 2-watt unit, 851 to 869. And those just are 3 individual physical filters. Now with our CS40 and the CS45, we have in the GUI, I can't really show you, I can show you where it would be, but we have this mode we call the Class A mode, which is kind of, this really should be a channelized mode, but in the channelized mode, we can select the bandwidth right here from 12.5 to 50 to 75 to 150. But if you go up here and change this mode to Class B, then in Class B mode, you're going to see 4 filters, and those 4 filters you can select to be that 4 megahertz wide, or 851 to 854, or 851 to 861, or a couple other different combinations for both 800 and 700 that covers those ranges. So yes, You would just leave the Class A mode, go to the Class B mode, and you could set up a filter for that.
Okay. Next one is a comment from Tony. Haggard Electric, we just deployed 2 of these systems and successfully uplinked them to PCER, and everybody who worked with Westell was outstanding. Thank you for all your help. I appreciate that, Tony.
Yeah,
next from Jim, can the master act as a standalone BDA, or must an RE be co-located at the head end?
No, it can definitely be a standalone BDA. It's you just order that master unit and don't call it a master unit, just call it a BDA, and those connections are there ready to go. In fact, that's one of the things that we recommend. If you have a project that you know that is going to expand, the building owner's already said, here's building number 1, and a year from now we're going to have building number 2. Instead of putting a BDA into building number 1, put in one of these units that can turn into a fiber DAS master, and it'll cover building number 1. And then when building number 2 gets built, and assuming it fails the grid test, you just run fiber over, add the HE and run fiber over to it, and put a remote unit in building number 2, and you're off. And that would be way easier and better than putting 2 separate BDAs. So yeah, definitely.
All right, thank you, Tom. Next one is from John. Can you log into the master BDA and see all the remotes under the user interface?
All right, so there's a little wrinkle there. So the answer to the question is yes, you can see them, which is a slightly different question than can you configure them. And so right now it is read only. So I can log into the master and I can see what the remote is doing, but if I wanted to adjust, let's say, the output power of that remote, I won't be able to do it. I'll have to log into that remote in order to make any changes.
Okay, that's an important clarification. From Dylan, will splitting the RF while daisy chaining HE units be compensated automatically, or will it need to be done manually?
Yeah, no, the HE and the RE have automatic gain control within themselves, and the levels will be compensated automatically. Great question, by the way. As
Okay,
are many of them. Yeah.
Yes, they are. Next from our friend Za, for about 2 million square feet data center building or factory-like building, can we extend more remotes, or any suggestions?
Yeah, so right now we are limited to the 8 remotes, which is 9 square footage, or excuse me, nine zones, or 9 times the square footage. And it's always a tricky question. You know, how many square feet can a BDA cover? Because there's no one answer. It all depends on how cluttery the building is. Right. The answer that we would have now would be to just put in a separate fiber DAS system. It would be possible maybe to share a donor antenna, and then the service antennas coming off of both masters could serve different parts of the building if the building is large enough that it would need 2 BDAs, and then run the fiber from there. But that would be a parallel system is what we've got right now. But again, just to clarify that, hopefully in the future, firmware update and testing will show that we can get more than 8, but we're just not quite there yet.
Yep. From Richard, what's the easiest way to access the units remotely if we wanted to change the configuration on them?
There's a RJ45 port right here that you can access that is meant for local control. And then on this board right here, you can't obviously see it, but there is another Ethernet port here, which is designed specifically for, we'll say, remote access. So you could go into the GUI, you can adjust the parameters of this RJ45 port right here, and then all you would need to do is get an internet connection to it, either the building's internet connection or cellular modem or whatever. And then you just can log into it. That's when I teach a class, I log into 3 units that are with our tech support, Kevin, up in New Hampshire. And no matter where I'm at, I can log into the unit, and it logs in through this port right here. So yeah, very easy to do. And because it's all internet-based web browser, it's extremely straightforward for anybody who does networking.
Thanks, Tom. Next one is from Stanley. AHJs require a test for antenna system isolation. They require us to inject signal into the server port. What is the power limit you recommend you don't exceed?
Do a follow-up question if this doesn't make sense to you. But, is the BDA needed for isolation testing? And the answer is no. Doesn't even have to be there. And what you do is you put a CW signal into the service antenna. Oh, well, maybe that's what you meant by service antenna port. Sorry if I thought you meant at the BDA. But yeah, you would put a signal into the service antennas, and that would have these antennas transmitting a signal, which would get picked up by the donor antenna, and there you measure it with a spectrum analyzer. So this is how you test isolation. Inject a signal, see how much comes back, and you subtract the two. So for example, if this signal generator was set to plus 10 dBm and the spectrum analyzer measured minus 100 dBm, you subtract the two and you would say the isolation is 110. So this is how you would do it manually. And then we also have a test within the BDA, so get rid of this and connect the BDA up as normal. There's an icon you can press. Let me just go back to this presentation. Right here, isolation test. You press that, and the BDA, it will do the transmitting of signal out of the service antenna and see how much comes back into the donor antenna. And it'll tell you more or less what the isolation is up here. Now with the CS45, as long as we have at least 110 dB of isolation, we can set the gain up to its maximum, which is 90. And the way that it's set up is if the isolation is 110 or better, it just shows you 110. So what you're looking for up here is 110. And if it just happened to be 120, it's only going to show you 110. But that's all you need to get the maximum gain of 90. So hopefully that answers that question.
Stanley, let us know if you need more clarification on that. Next one is from Jeff. Is this product approved in Canada? I'll answer that. The answer is no. Next one is from Jim. When using 4 or more REs, how is uplink noise mitigated to meet FCC in-band and out-band specs? Is there a location to place SMA attenuation on the output side of the uplink PA?
Yeah, so the only uplink PA is on the master, and there is no SMA port there. So if you needed to attenuate the output of the uplink amplifier, it would have to be an N attenuator on the outside of the unit. Now there's SMA connectors on the HE and the RE and the connections, and those are all SMA connections. And if you wanted to lower the noise from each remote going into the master with an SMA attenuator, you could certainly do that. But with fiber DAS systems, yeah, every remote is going to add some noise.
All right, thanks, Tom. And the last question we have is, what is the maximum uplink input power to the REs or the BDA?
Yeah, again, that's depending on how you want to measure it. So there's the absolute maximum. Don't go above this or you might blow it out. That's plus 10 dBm, but we'd recommend no more than 0 dBm. And then there's the question is when does it kind of self protect itself? So the signal's not anywhere strong enough to damage it, but it's strong enough that it would overload the front end and thus cause problems on the A output. And that happens around minus 50 dBm. That's when that would happen. For the Westell products, it's very easy to figure out. If you want to know that level, you take the maximum output power, which for uplink for us is this case plus 27, and then you subtract the gain. So 27 minus 80 will give you that value. So what might be a little higher on uplink, so that would be 27 minus 80. So around minus 53 dBm. It'll still work. Nothing will happen, but the unit will start adding additional attenuation to protect itself. Great questions, by the way. And we gave this webinar a couple of weeks ago, the first time. We had some really good questions then, too. So thanks, everybody, for paying attention and asking good questions.
Any plans for having 2 HEs for backup? I'm assuming that question is related to redundancy.
I would think so. I don't know of any plans for that.
None that I'm aware of.
Yeah.
We do have another one. Is there any plans to place a cellular modem in the master to allow for remote shutdown?
Yeah, so we allow remote shutdown through the GUI. This is right here. We call it emergency transmit disable. So it doesn't shut off the power, but it shuts off both, or I should say all 3 power amplifiers, the 1 uplink and the 2 downlink. So once the emergency transmit disable becomes active, the unit shuts up. Nothing comes in or nothing comes out of it. And it's just a matter of if you have the remote connection, you can do that. Now, will Westell provide the modem? Bob, you might want to mention it. We mentioned something about a remote box. Where are we at with that?
It's currently going through field trials with a customer, so still probably a month or so away from a product announcement on that.
Yeah. So, yeah, that can be done either just through normal networking and hitting that emergency transmit disable icon. And as far as there's a lot of jurisdictions that's using ResponseLink. It's been tested with ResponseLink. It works just fine. Yeah, it uses SNMP, uses IP. Yeah, so just about any box that is designed to do it will work.
Yep. Another one from Richard. Have you guys thought about doing a touchscreen version of your BDAs to access the GUI with a password to eliminate needing a laptop or phone to program?
That I would say no.
I agree.
And I think that's about it.
That's a wrap. Thank you, everybody. Thanks for joining.
Thanks, everybody. See you next time.
Take care.